Hi. Here are your solutions to numbers 1 through 7 on the Looking for Pythagoras Investigation 2 checkup. Number 1, they ask you to make a square using this segment as one of its sides. And the way that you're going to do that is you are going to use the slope of this line. So up 2 and right 3. You're going to use the opposite reciprocal, which means I'm going to go down 3 and right 2, and that's going to be my new point where one of my vertexes will be. And go to the other side and do the same thing, down 3, right 2. There's your point. And then you're going to just connect them. Using a ruler, not using a ruler, I was looking for the points. So if you had the point in the right spot, if your line isn't perfect, that's fine. But if you have issues with drawing straight lines, you might want to grab a ruler when we're doing those. The next problem says, find the area of this square. So we want to know how much space is happening inside this. Some of you may have counted up the dots inside to see if we've done one before. The way that I suggest doing this is following those step-by-step instructions that we did before. So we're going to box in our square, meaning we're going to draw a square around the square. We need to enclose everything as far to the left and right, and as far to the top and bottom. So we want to make sure everything is on there. Sorry. All the way back. Green line again. This way it matches the colors that are on our practice sheet when we were doing them. So the next step on there after we box this in is to find the area of this green box. So it's 1, 2, 3, 4, 5 by 5, right? It's a square. And so 5 by 5 gets you an area of 25. Sorry about my writing with my mouse. Ooh. The next thing we need to do is subtract the area of our triangles. So these pieces over here, over here, over here, they're not part of that original square. So we need to take those away from this 25, which is the green box. So each one of these triangles is 1 by 1, 2, 3, 4. So it's 1 by 4. And to find the area of a triangle, we multiply base times height and divide it by 2. And 4 times 1, 1 times 4 is 4. And 4 divided by 2 is 2. So each one of these triangles is going to have an area of 2. And that's what we're getting rid of because we only want the square inside. So 2, 4, 6, 8 is what we're going to subtract. And then we're left with an area of 17. And so this would be 17 units squared. That's your solution. The next problem, we have to go a step further. So we want the side length. We want to know how long is this? So we're going to do the exact same thing. We're going to box it in. And we're going to subtract our triangles to find the area of that original square. this box that we just drew is 1, 2, 3, 4, 5 by 5 again. And so that's 25. Write these measurements so that you know where that 25 came from. And then we're going to, again, subtract those triangles. Each triangle, 1, 2 by 1, 2, 3. So 2 times 3 divided by 2. 2 times 3 is 6. 6 divided by 2 is 3. So each one of these triangles has an area of 3. So all together, we're going to subtract 3, 6, 9, 12. And we're left with 13. And that 13 is telling me that the inside, whoa, inside that original square is 13 units squared. That's the area. But we're not finished yet because this question asks for a side length, not for the area. So I know that if the area is 13, the side length is going to be the square root of 13. Remember, we don't want to think about it. We just want to remember whatever the area is, you take the square root, and that's your side length. Because if I multiply the square root of 13 by another square root of 13, the other side of the square, I would end up with 13 for my area, right? Base times height would get me my 13. Number 4, again, we're going to find a side length. The difference of this is that they did not draw the square out yet. So we have to go back to just like what we were doing in the first problem. We have to actually find the slope of this square or of this line segment, and then we're going to make a square out of it. So I go up 2 and write 1, 2, 3, 4, 5. So to do the opposite, instead of going to the right 5, I'm going to go down 5, 1, 2, 3, 4, 5. And then instead of going up 2, I'm going to go to the right 2. And here's my new spot. And from this side, again, down 1, 2, 3, 4, 5, and right 2. So this is what we want to find the area of, and then we'll take the square root of that area to find our side length. So back to boxing it in. Get my green, and I'm going to box this in. Find the area of the green box. It's 1, 2, 3, 4, 5, 6, 7 by 7. 7 by 7, which is 49. And we need to subtract our triangles, and our triangles are 2 by 1, 2, 3, 4, 5. So again, 2 times 5 divided by 2, which is 10 divided by 2 for a total of 5. Each triangle has an area of 5 that we need to subtract. We're total going to subtract 5, 10, 15, 20. And 49 minus 20 leaves you with 29, which means the area of that original square is 29 units squared. Oops. But the side length is going to be the square root of 29 units. All you do is take the square root of whatever that area is. That's how you find the side length. In number 5, it says Ella drew the big square and says the length of segment CD is the square root of 18 units. So maybe she boxed it in and subtracted her triangles, and what she was left with for the whole big box or big square was 18, right? 18 units squared for the area of this whole big box. But what they're asking for is length CD, so that would be the square root of 18. So from C to D, square root of 18. So now they say Oscar drew in these smaller squares, right? We can separate, and I'm going to change so that's not the same color, but I could draw this line all the way down, right? Could separate this box into a bunch of these little pieces. But we're only interested in how long is this segment from C to D. So really, we're just going to look at one of these boxes. If we know what the area of this box is, it's going to be the same here, and it's going to be the same here. These are all exactly the same length. If you go back, you can look in your papers and find one dot inside means that the area is 2. You could box this in and figure that out, that it was 2, which I think we'll just do really quick. Just going to box this green square in, right? And so this is a 2 by 2 square, which is 4. I'm going to subtract the little triangles around, and each triangle is 1 by 1. And 1 times 1 is 1, and 1 divided by 2 is 0.5. I'm going to try and do that 4 times, but 0.5 plus 0.5 plus 0.5 plus 0.5 gives you a total of 2. And 4 minus 2 tells me that the area of this little square is 2 units squared. And even more importantly, this line from C to here is the square root of 2. And from here to here, also the square root of 2. And from there to D, also the square root of 2. I didn't actually write this one in. So altogether, C to D would be 3 square roots of 2. That's another way of saying it. And you could do this mathematically. We had the square root of 18, and we can break that up. If you remember, we're looking for a perfectly square number that will divide evenly into 18. That would be 9. So we can instead write this as the square root of 9 times the square root of 2, because 9 times 2 is 18. And then we can simplify the square root of 9 as 3. And the square root of 2 cannot be simplified without writing it as a rounded off decimal, right? If we want the exact amount, we got to keep it underneath that square root sign. So that's 2 ways to show how you could have written that 3 square roots of 2. Couple more. If a square has an area of 5 inches squared, what's the exact length of its side? Well, we just talked about this over and over again, right? Here we have the square. If the area inside this square is 5 units square or 5 inches squared, then what would the side length be? Only thing, take the square root. Square root of your area is your side length. This time they're in inches, and it's a side length. None of that is squared. You don't do the square root of 5 squared. You don't do the square root of 5 inches squared. It's just the square root of 5 inches. That's the exact length. If you put it in your calculator and find what is the square root on the calculator, you're going to be rounding your number. So again, when it says exact length, they want you to leave it there like under the radical sign. And finally, for number 7, no calculator used for this. They want to know between which 2 consecutive whole numbers does the square root of 53 lie? And we talked about this using the square root cheat sheet that you had. You're going to find perfectly square numbers on either side of 53. So the one lowest before going over 53 would be 49. And the one that comes after 53, the very next one would be 64. And you can see 53 would fall right in between those two, right? So if we take the square root of these, which I'm going to have to draw, which is probably going to get sloppy looking, but square root of 49, square root of 53, square root of 64, right? That makes sense that those would fall in there. So the square root of 49 is 7. And the square root of 64 would be 8. So the square root of 53 is going to be in between the square root of 64 and the square root of 49. That would be consecutive whole numbers, 7 and 8. Those are counting order, right? You would count by saying them in order, and they don't have a decimal, they don't have a fraction. Those are whole numbers, 7 and 8. If you have any questions about any of these and rewatching the video doesn't help, please come in and see me. Let me know, and we can get it worked out before you try your retake. Have a great afternoon or great day, depending on what time you're watching this. And I will see you soon.